Hi, welcome back to the breadboard, and for those in Canada, happy Canada Day weekend. Cheers. Hope you had a great weekend. So I'm a little bit late with a Friday video, so it's now actually Sunday and I'm doing it because, well, it's Canada Day weekend and I've been having a bit of time off. So what I want to share with you today is an IoT device that really makes an Arduino Uno, even a eBay special one, look rather expensive, and can do most of the things that people use an Arduino Uno or a Launchpad or a Raspberry Pi for, but much cheaper. And I'm going to show you how to easily reprogram it so that you can use it in your local network without having to rely on cloud services and things. And we'll go through a few of the specs of it and so a few examples, and I'll share with you some of the work that a friend of mine, Pete Scargill in the UK, has been doing to allow you to reflash this from its production code, which really allows, forces you to use a cloud service or to talk to it as a serial device, and allows you then to expand its capabilities to way beyond what it comes from the various manufacturers and vendors. The device is also now programmable via the same Arduino IDE that you use for your Arduino Unos and Megas and everything else. So you can program it with the same old familiar application IDE that you used to, without really having to worry about the underlying complexities of what this chip actually is. So let's go have a closer look and you'll see what I'm actually talking about. I'll show you how easy it is to program it with the ROMs that my lifelong friend has developed for these, Pete Scargill, and what they now allow you to do once you've repurposed them using his code. So let's go have a look at the boards. So if you haven't already guessed, then I will now let the cat out of the bag. What I'm talking about are boards that are based on the ESP8266 controller. This is a little microcontroller that has full Wi-Fi capabilities built into it. It's A, B, and N, and coupled with an external flash ROM allows you to write some quite comprehensive applications, because the flash ROM can be, anything from about 500 kilobytes up to several megabytes in size. Just depends on what chip you want to couple up with it. So what we're looking at here are a number of boards that are from a company called ITead Studio, and then some of the other boards are from eBay, from various vendors. If you just search for ESP8266, you will find plenty. So what we have here is this first one, which is a main one. I have a lot of these that I'm using for some applications within my home for IoT apps and automating my house. These are called a SONOFF, and they'll work from anything from 90 to 250 volts. They have a relay on board capable of switching up to about 10 amps of whatever supply you happen to be using. They have a built-in power supply buck regulator, which takes the mains and supplies the ESP8266 flash ROM and the supply capable of driving the relay. And what this will do is, out of the box, when you get it from ITead Studio, it will allow you to configure it to talk to ITead Studio's cloud service, and then they have a smart app for either an iPhone or an Android phone. But what if you have your own smart network and you don't want to rely on a cloud service? Well, a friend of mine, Pete Scargill from scargill.net, has created a new version of the flash for these SONOFFs and any ESP8266 for that matter, that allows you to use your own designated MQTT server that you can configure either at home or by using any of the many offerings that are available for free or for a fee on the internet. For instance, the IBM MQTT org or Eclipse. They all have offerings that you can have for free and test with. But you can also download MQTT for yourself and run it on a Raspberry Pi or any Linux and even some Windows-based systems too for free. So there's lots of options for you there. And once you reflash these with Pete's code, you can then point it to your own MQTT server, couple it with something like Node-RED. So what do I actually have here? Well, I've already mentioned that I've got the SONOFF. The one on the left here is a Slampher, which basically inside here is the exact same electronics basically is this. This is rated at about 2 amps. The other one here is very much like the SONOFF, except that it's 5-volt powered, and it still has the 10 amp relay, but it doesn't have the switching regulator. And you program all of these through using a transmit and receive line, and you give it 3.3 volts. These 3 in the middle here are various versions of an ESP8266 board that you can get off the internet, particularly eBay or AliExpress and places like that. This one over here is an ESP01, which actually gives you 2 I/O ports. This is, I think is an ESP13 or something like that, and this one is ESP10. I think the numbers reflect generally what number of I/O ports are available to you. Now, the thing to remember here is that just because they have a different number of I/O ports, they all use exactly the same ESP8266 in all of these. So all of the I/O pins are actually available on the chip itself, and it's just the only difference is really what they've brought out to the I/O pins. In the case of this white one and this little one here with the can on it, there's a lot of I/O pins brought out, including the I2C bus and things. This one here only has 2 GPIO pins brought out to it. But, you know, I've seen people that have unsoldered this 8-pin header and added, say, a 16-pin or something like that, missing a couple of pins in the middle just to clear the edge of the board, and just fine wire soldered a few of the extra GPIO pins onto it to get a little bit more I/O. In most cases, you know, it's worth just spending the extra dollar just to get the bigger board, to be honest. This big white one also, as well as having the built-in antenna, it also has a micro connector so that you can actually put your own external antenna on it as well. All these other ones have built-in antennas, and basically this little PCB trace, and they can all be programmed using a 3.3 volt compliant COM port from your computer or whatever else you happen to be using to do the programming. It doesn't matter if it's Windows or Linux or OS X or whatever else. You can actually program these very, very straightforward through just a simple serial port. It just needs to be 3.3 volt compliant, that's all. These, as their default configuration when they come from eBay or various other places, effectively behave as a modem. It's just that the medium that it's talking across is actually standard 802.11 AB or N Wi-Fi rather than a phone physical line. These other ones all, of course, talk to the same Wi-Fi networks as well, because they're all based on the exact same chip. Now, the other significant difference in these is that the SONOFFs come with an 8 megabit flash ROM on them, so it gives about 1 megabyte of available space, whereas the ESP 12, 13, and 1 all come with about half a megabyte, so a 4 megabit flash ROM on them. Half a megabyte is more than enough for pretty much any application you're going to do. Remember, though, these things can easily replace most of the IoT apps that you use an Arduino Uno or something for, and these have got 512 kilobytes of space on them, whereas an Arduino Uno has 32K of space. And they now also have a development environment which is using the exact same IDE as an Arduino Uno or Mega or Yun or whatever else you may be wanting to use. So they are basically, for most things, fully comparable to these. All right, what we have here is we have an Arduino Ethernet. Well, these don't have an Ethernet on them, but they do have the Wi-Fi, so you still have your IP connectivity. This is an Arduino Uno, and I've already mentioned some of the differences there. If you wanted to use an Arduino Uno with Ethernet or Wi-Fi, you would actually have to add a daughter board to it. An Arduino Yun here, this has got built-in Wi-Fi and also Ethernet, but it's not cheap. And then this last one here is an Arduino Teeny, which is basically just another Arduino Uno, but more towards breadboarding. But either way, all of these, you know, most of these, especially if you buy the pucker ones, they could cost you $10, $20, or more, $30 to buy one. And if you buy the eBay specials or the clone ones, you're still paying sort of like $8 to $10 for most of these as well. Whereas when you buy these, all right, the SONOFF itself can be had for about $5. All right, the prices vary from time to time, but you can get these for about $5, and they've got the Wi-Fi in, they've got the enough I/O that you could put a temperature humidity sensor into it, and it can control a relay that could turn on and off a up to a 10 amp heater or something like that, or control something else, or go via a bigger relay to control even bigger circuitry. These other ones, you would have to add your own drivers to drive either a relay or up to a couple triacs or whatever else it might be. But either way, they're very, very easy to interface, and they're just as easy to interface as an Arduino or a Launchpad or a Raspberry Pi is. So let's go, and we'll go out to the computer now, and I'll show you how easy it is to actually reprogram one of these. So I'll pick a SONOFF, and then I'll do the same thing with the ESP13 and an ESP01, just to show you. I can't do this because I don't have a breakout. This is not this particular one does not have a 0.1 inch pitch connector on it. Let's see if I can get that to focus. It's a little bit of a funny pitch on this connector, so I can't interface to that unless I just simply put flying wires on it or something, and I'm not going to do that. And I think the principle is the same no matter which one of these you use. So I will do one of these, and one of these, and show you how easy it is to hook up, and then I'll show you it running with MQTT and a simple Node-RED application just to do this. So let's go and get to the computer. So the first one we will have a go at programming is the SONOFF, and what you can see here down in here are 4 little headers that don't have a connector, and the first thing we need to do is to put a 4 little 0.1 inch pitch pins in there so that we can plug in our programming header. What you've got is plus volts, ground, and then the transmit and receive pins are in the middle. So just going to go do that and be right back. So we now have a header put on here, and the pin at this end is the plus, then you got transmit and receive, and then you have ground, and the last pin is actually a GPIO 14, I think. So nipping over to ITead Studio's website, they have a little bit of information about programming the mains controllers, the SONOFFs. It's not got everything in here, but it certainly gives away a few useful pieces of information, mainly what the pinouts are and things like that. Now, they have a whole bunch of boilerplate logic for programming using the Arduino IDE. There are plenty of various sites that actually detail things for the Arduino and for the IDE, and also for programming the ESP8266. GPIO 0 in all cases is always used for putting the device into programming mode, as I've already said, but often in a lot of cases it is also used to initialize Wi-Fi programming mode or other options if you so wish. The key thing is that when you power it up, if it's being pressed, it will go into programming mode. Once it's powered up, you could use it to maybe do a local on-off of the relay if that's what you've got connected, or anything else that you may choose to use it for. This is the connector that we were looking at. So this says SCL, which is actually this one here, which is physically pin 9 of the ESP8266. But that correlates to GPIO 14 when you're programming it as well. Going back to the programming of this, one of the applications that I found, which I think my friend's Pete Scargill's site refers to, let me just bring that up. Here we go. So this is on tech.scargill.net. This is Pete Scargill, my friend, who's done a lot of work with programming the ESP8266s, and he's regarded as an ESP8266 hero now in the various communities, as he's put so much effort into this. I'm just using his code. Him and I have worked a lot of things trying to debug various aspects and talking through different ways of doing things, but he's done a lot of the legwork, or pretty much all of the legwork, along with his UK friend Aidan Ruff, to get this thing up and running. And they actually have some boards that they also produce that have relays and temperature sensors and various other things on it that you could make. The actual Eagle files are available on his Bitbucket site, so you can just download them. Anyway, the point here is there is a little programmer here, if I just make that bigger right now, called Node MCU, which is a firmware programmer. And with this, you don't actually need to load up any IDE or anything else to do the programming. You just have to get a hold of the binary files. And Pete actually has these on his site. I will provide a link to them in the post. His site doesn't actually show up a lot of the programming things terribly well. He's already told me he's going to change the linking to make it a little more obvious. Root bin and ROM X bin that you can just simply download, and you'll get the code as it stands right now that you can just simply flash into your ESP8266. Now, what these boards do is they actually look for a MQTT and Node-RED service running. So this is a little example of a Node-RED page, block, if you like, whatever you want to call it, flow. And what this is doing is it's looking for a login statement coming from MQTT. And if it finds it, it actually provides a reply to the caller to give it things like the date, time, and things like that. It basically a little bit of initialization, and also to acknowledge that it's there on the network. Also, the MQTT service is expected normally to have a username and password. You don't have to configure it, but you should, especially if you're using it for controlling your house lights or locks or anything else like that. Anyway, I will show you how to do this in a moment. First thing we need to do, of course, is to program the flash. So I've already downloaded these two bin files, so I have access to them locally. And the other thing you need is this Node MCU firmware programmer. And you can download this from the internet. Here it is, the link to the Node MCU right here. So this is how it starts out, and I haven't plugged in any of my modules yet. So how about I plug in the one that I've just added, which is this one here. So what I'm actually using is a Silicon Labs CP210X USB to UART bridge, and it shows up in my particular system as COM5. So I've just simply plugged that in here, leaving this last pin unconnected. Now right now I didn't have the programming pin here pressed as I plugged it in. I just wanted to show you it connected there. So let me just adjust this and we'll get it into programming mode. Okay, so I'm just going to disconnect the power to this and reconnect it while holding the programming pin this time. So I'm just pressing it now. I'm going to unplug the connector, and then while I'm holding it pressed, I'm going to reconnect the power. And it should put it into programming mode. Now you won't see much difference except the fact that the light is no longer flashing. And then when I let go, it is now in programming mode here. Just adjusting the camera suitably. There we go. So now what I'm going to do is change this to COM5 because that's the one I'm on. In my configuration, I need to pick my two ROMs, and in advanced I need to set the programming. Now in this case I've got a 1 megabyte flash, and I can use QIO mode, and I can program faster if I want to as well. In the config I need to pick the two flash ROMs. So the first one, the rboot.bin, we'll open that, and the next one is the romx.bin. Now I downloaded these just into my videos folder just for convenience, and we need to make sure we set this one. See, the 200 is 2000 is not an option here, so we need to type it in. So OX2000, it's not 20,000, it's just 2000. And that's all you got to do there. 115K2 for the baud rate, 1 megabyte flash that's in here, 80 megabytes in the QIO, which is quad IO mode, which is a little faster way of using the flash. We select COM5. We've already been pressing the button when we powered up. So if everything is connected correctly, I should be able to just hit the flash button and it will program. So let's give it a go. Bink. And there we go. Immediately identified the MAC address and the STA MAC as well for the device, and so it's now programming it. Now that seemed to be a little fast, so I'm just going to check my config. Oh, I didn't select it. There you go. Classic mistake, and Pete even mentions it in his website. Even though you selected this, it doesn't automatically check the checkbox. So we'll check the checkbox, go back here, and we'll hit flash again. And this time it'll do that, and then it'll go on to do the second one, as you can see it here. So now it's programming correctly. Lights are flashing on my little UART USB to COM port adapter. You can't see that, but anyway, it's busy reprogramming right now. Now you notice here I haven't written any code yet. I'm actually just going to be using Pete's code the way he's written it. It's very flexible. It has a lot of things in it which would cover most people's requirements for a home automation system. But all the source code is available on Bitbucket that you can download and do for yourself, or you could simply choose to use the code that you can download that's been done on ITead Studio site for Arduino and roll your own if you want. So that's done. So we just need to exit this. We just need to reboot the ESP board. So I'm just going to unplug the power and plug it back in again. Now what will happen is the light will start flashing, as you can see there, I think faintly. Just shadow it a little bit. And that's just saying that I want to be configured. All right, it hasn't been configured yet. It doesn't know what mode it's got. It doesn't know what MQTT server to use or anything else. I'm just going to move this display over because I need to find my terminal program. I'm using TerraTerm. So here it is. I'm just going to put it in an empty space. Let me just move things around a little bit. New connection. We're going to serial COM5, say OK. Now we need to switch it to use 115K board, but that's the only change you need to do. Say OK. Now that we're here, you'll see that there's actually messages saying that it's waiting for an access point. That's called beyond. That's just a default name that's in here. And if you look at the manual, I will provide you a link to it. Here's a Word document that details the whole of this. So if I just say squiggly bracket debug and close that off, it'll actually tell you what it's currently configured for. So you can see here that it's got dusk and dawn. IP doesn't have an IP address yet. Its SID is looking for beyond, and its SSID, passwords, MQTT host, port number, MQTT username and password. OTA, I didn't tell you, but this also supports over-the-air reprogramming. The frequency of the CPU that it's currently running at, which is 80 megahertz. Now you can actually flip that up to 160 megahertz if you want to, etc. So what I'm going to do is just quickly set up the MQTT server, and so the commands are actually all in a Word document. If I just open it up, I think I have it locally stored. So here we go. So this is his Word document. It was updated in the middle of May, so just a couple of weeks ago, and it talks all about it, and then it goes on and alphabetically goes through all of the different commands that are available. The one I just typed was debug, which showed me some of the base configuration information. Now you will notice that in his documentation he shows here clearly that when you do this over MQTT, it does not send back the debug information. It'll only put it out of the local serial port. Part of that is for security reasons. If you had somebody that actually managed to send an MQTT command and subscribe to your MQTT server, the last thing you'd want is for them to start discovering all of your nodes as well. So this will only show it on the serial port, which means that unless you're physically connected to that device, you're not going to see any of this debug information. So the bits that I'm interested in right now are actually the, skip through here a little bit, MQTT host, MQTT password. The port is already set, and the other parts that I'm interested in are the password and SSID. So there's the password for the SID, and also the one that RS. Let's go through. It's all in alphabetical order now. So set serial, that's not it. SONOFF there, SSID. This allows you to set the Wi-Fi SID. You can actually set two of them, so if it doesn't get connected to the first one, it will try the second one. As I said, I will provide a link to this manual. You can download it and have a look at all the commands that are available for yourself. So let's just minimize that. So now in here, I need to set up my devices. So the first thing I'm going to do is say MQTT underscore host. Okay, so those credentials are now correct. So now if I reboot this device, this light should now, because I do have an MQTT server set up. If I just bring up Node-RED for a second, I will show you that. So I have this ESP logon, which will actually receive a logon request from these ESP8266s once their program repeats information. In here, what you do is you tell it your longitude and latitude, and it will figure out the dusk and dawn times for your device, and it will also set the clock on the devices when they register with the MQTT server automatically. Or sorry, when they basically register with Node-RED. This is actually going through MQTT. Node-RED is listening and then sending out a packet to register the device with the Node-RED so that it can use it. Okay, so what I will do now is I will power the device on, and it's managed to get a time accurately, so 7:41, which is the correct time, 3rd of June 2016. So that's all actually worked quite happily. I think in Node-RED, if I had debug turned on, it will also show me the request. So here it is. It actually asked, right, there's its name. It was an ESP logon message, which came in here because that's what this is registered for. And it managed to then send back out again. This is the time, and then dusk is 1,261 minutes before midnight and 338 minutes after midnight. So it sounds like a weird way of doing this, but it actually works out very, very well. That's really all it takes to configure any of these ESP8266s and get them onto a local MQTT server. So let me just quickly hook up the other two. I'll show you how to program them, and then I'll just verify and show you how to quickly put together a little application on one of them using Node-RED so that we can read the ADCs and so that we can actually maybe turn a relay on and off or an LED or something depending on what you have hooked up. So this is the ESP201, which is the whiteboard that I have, and what you need to program this one is a few extra connections. The actual header for programming is the same, but what you have to do is you still have to ground GPIO 0, which is this one pin right here that's labeled 15. That you have to connect to ground, but you also have to connect the chip enable, this one, to ground as well to enable the board to operate. Sorry, you have to connect chip enable to VCC to enable the board, and GPIO 15 also has to go to ground to tell it to boot from the on the external flash that's been provided. So what I'm going to do now is hook one up. Let me just bring up the camera. So now let's just power this up, which I've done, and we'll bring up the flasher and make sure that we can program this one as well. So here we are with the programmer. As I said, we've got this one plugged in this time. So we flip to COM5 again. In the config, we've already got the same bit set up. Now, in this case, we need to change it to be 512 bytes of program space. Everything else can stay the same, theoretically. Make sure we have both checked, and that should be enough to now program. There we go. It's done the first part. We've got the MAC address and the STA MAC, access point MAC and MAC. Okay, programming is now done. So I'm not going to... Now, programming the other boards is basically the exact same process. So It's just a case of grounding GPIO 0 while you power up. Make sure the board is enabled. On these little ESP01s, you still have the same requirement to enable the chip. And what I've done is, as you can see there, I've just put a little loop from the enable pin to get it going, and then just basically the 4 wires which go out to the programmer again, and outside of that it's exactly the same. And then as I power this up, I just ground GPIO 0 and it will program in exactly the same way. So here is a typical layout of the ESP01s, and this is the ESP8266 chip. This is the flash. And you can see here you've got the transmit, chip enable, reset, 3.3 volts, receive, GPIO 0, GPIO 2, and ground. So all you do is you connect ground and 3.3 volts to your respective supply. You take chip enable to 3.3 volts so that it will power up and be enabled right off the bat. And then you just need to connect the transmit and receive to your UART. Power up by keeping this pin grounded, and then you can let it off, and then you can program it exactly the same as the other ones. Anyway, so that's the pin out of an ESP01, and all you need to do, whatever ESP board you get, you just need to figure out where is GPIO 0 so that you can ground it while you power it up, where is the transmit, receive, and the power lines, and that's pretty much it. So that's the other one programmed. So let's go look at setting up the MQTT server and Node-RED so that we can actually talk to one of these. I'm going to put an LED on one of them, and I will have a relay connected to the other one. Okay, so what we have here is I put the SONOFF back in its box and connected mains to it. You can see that as soon as it powered up, it's automatically re-established its connection. And the ESP201 over here is got this LED connected. It's just flashing away here, and it also connected right away as soon as I'd put in the parameters for the MQTT server, which we had done before. So that's now flashing to say that it is connected. So I'm going to reconnect that particular pin for the LED onto its GPIO 12, which is equivalent to the LED, so that we can actually play with it using Node-RED and MQTT. So let me just do that now. Okay, so that is no longer connected to the standard green LED pin. I've now connected it to the relay output. So we have both controllers now sitting here with their respective control signals all set up, their parameters all set up. So let's go and look at the Node-RED and MQTT server so that we can see what's happening.